Good morning to everyone. Myself, V. Sivaraman, Associate Professor, Department of Mechanical Engineering, Sri Muthukumaran Institute of Technology. Today I am presenting a lecture on the subject Process Planning and Cost Estimation for Mechanical, Mechatronics, Robotics and Automation Engineering students of BE Regulation 2021. Course code CME396. The objectives of the course. By the end of the course, the students should be able to understand the methods and principles of process planning and select appropriate tooling, equipments, and process sequences. You should be able to estimate the production cost, including labor cost, material cost, and overhead costs. Also able to compute machining times across different operations. Syllabus. Unit 1. Introduction to Process Planning. In this unit, we see the introduction, the methods of process planning and drawing interpretation, material evaluation, the various steps in the process selection, and production equipment selection and tooling selection. Unit 2. Process planning activities. In this unit, we are covering the process parameter calculation for various production processes and selection of jigs and fixtures required for the process and the quality assurance methods used in it, the set of documents required for the process planning, and the economics of process planning with case studies. Unit 3. Introduction to Cost Estimation. Here we are seeing the importance of costing and estimation, methods of costing, elements of cost estimation, types of estimates, the procedure of estimating, and estimation of labor cost, material cost, and allocation of overhead charges, and also calculation of the depreciation cost. Unit 4. Production Cost Estimation. So the estimation of different types of jobs are seen in this unit. Estimation of forging shop, welding shop, foundry shop, etc. Unit 5. Machining Time Calculation. Here we are seeing the estimation of machining time, the importance of the machining time calculation, and calculation of the machining time for various operations like lathe operations, drilling operations, boring operations, milling operations, shaping operations, planning and grinding operations. The course outcome of this subject are: first, the students should be able to discuss select the process, equipment, tools for manufacturing various industrial products. And he will be able to explain preparation of process planning charts. And also he should be able to explain concept of cost estimation and compute the job order cost for different types of shop floor production such as foundry shop, welding shop, and forging shop. Finally, calculation of the machining time for various machining operations. So coming to this subject, first unit is Introduction to Process Planning. So here, process. What is a process? A process is a set of interrelated or interacting activities that transforms inputs to outputs. So there we are giving some inputs and we are doing some process and we are getting the output. Then what is process planning? Process planning is the process of determining sequence of operations required to manufacture a part or product efficiently, economically, and with required quality. That is, without compromising the quality, we have to produce the component economically. It is one of the crucial steps in manufacturing and production engineering. So the process planning is done after completion of the design process and before the start of the manufacturing process. So in a company, first they have to design a component, a product, and then they will go for the manufacturing. But in between these two stages comes the process planning. So the process planning bridges the product design and manufacturing process. So we see the flow chart, the functional design, product design, drawing and specification. These are design part, and the bottom we have the modification of the process plan and manufacturing. This is manufacturing part. In between these two stages, there comes the process planning. So what are the key elements of process planning? Interpretation of design, taking make or buy decision, selection of manufacturing process required, deciding the sequence of operations, selecting machines, tools, and selecting jigs and fixtures required for the process, and selecting the material, and the time estimation and cost estimation, and finally preparing a route sheet or process sheet, which is the output of process planning. So coming to this process planning procedure, see, first the process planner has to study the drawing completely, detailedly, and then he has to select the raw material, and he has to select the machines and work centers required for producing this component, and also he has to select the tools, jigs and fixtures, and decide the sequence of operation, And also he should select the proper appropriate cutting parameters, cutting speed, feed and depth of head, and inspection stages, types of inspection, instruments for inspection, and he has to estimate the time of production and cost of production. Finally, inputting all these data, he has to prepare a process plan that is called root sheet or process sheet. So what are the details required for process planning? So we need a detailed engineering drawings, knowledge of materials for manufacture, knowledge of manufacturing process, knowledge of jigs and fixes, knowledge of the relative costs of materials, process and tools. So manufacturing parameter details, speed, cutting speed, feed and depth of head, and also knowledge of inspection, quality assurance, procedures and specifications. The factors affecting process planning are volume of production. So the volume of production is more. A plenty of component has to be produced. You can go for costly machines, computerized machines, automatic production, we can do. If the volume is less, then we can go for a conventional machining operations. So next is delivery dates for products. If the delivery date is we are having a long period, then we can go for a normal low cost machines. But if you want the delivery time is very less, so we have to go for higher producing, higher products machines having higher production rate machines, which may be costly, but we have no other way to select those machines. Then the accuracy and process capability of the machines available in our company, and also the skill and experience of manpower available in our company. So the workforce is the major asset of a company. So what is their experienced workers, what is skill of them is required. It also affects the selection of process. Then specification of the material used. Based on the material used, we have to select the different machineries. Hard material, we can go for high machines. That is the machines with which we can stand higher machining forces. Accuracy required in the products and components. What are the accuracy required for the actual component? It also decides the selection of machines and processes. So the general approaches to process planning are, so the process planning we can go for manually or computerized. So manual process planning and computer-aided process planning. So in manual process planning we have traditional approach, workbook approach. In the computer-aided process planning there are two methods, variant approach or it is called as retrieval type approach and the generative approach. So manual process planning. The process of preparation of process plan manually is known as manual process planning. The task involves examining engineering drawings, making decisions on the process selection, equipment selection, tooling selection, etc. So therefore, manual process plan is very much dependent on the skills, judgments, and experience of the process planner. If the process planner is skillful and experienced person, we will end up with a good process plan. Otherwise, we will end up with a poor process plan. So for doing this process planning manually, the details as already specified as drawing details, dimensions, surface finish, harness, etc. are required. Also about the various types of machines, the capability of each machine should be known. So in the manual process planning, the process plan studies the drawing, he makes some logic decisions and prepare a process plan and gives for the part producing. The planner studies the engineering drawing and finds out the requirements for manufacturing a component. He selects various processes and machineries required for manufacture. This will depend upon the quantity to be produced and capability of various processes. Based on availability of the machinery, he prepares a process plan. So merits of manual process planning. This manual process planning, it is very flexible, low investment, it's suitable for small scale companies, it works well with conventional machine shops, and also unique components, repair works and prototypes can be planned effectively, and it is suitable for complex and non-standard components. The demerits of manual process planning, it is very time consuming, it is lack of consistency, that is, if you give a process planning job to different persons, each person will end up with different process plans. And also with the same person, it depends on the time. At one time, he may prepare one plan. If the same work is given some other time, he will end up with a different process plan. Since humans are involved, they are prone to human errors. And also the output depends on this human skill. So it is difficult to standardize and the documentation is very poor. So computer-aided process planning. So there are two methods as I told, variant or retrieval process planning, generative process planning. Variant or retrieval process planning. It is focused on identifying similarities among components and retrieving existing standard process plans from a database based on the part family to which a component belongs. So the components based on their shape and size, they are grouped as families. It's called group technology. So based on that, the component belongs to which family, they will get a process plan which is already present there in the database, and they do the required editing work to shoot the current job and prepare the process plan. The next is generative process planning. The generative process planning approach involves the automatic creation of process plans directly from part design information. That is, they are starting from scratch. There is no already prepared process plan. So each time the work is given, they start from scratch. They get the design information, they start working on the process plan. So without relying on the previously defined standard plans. So retrieval or variant type process planning. In this type, computer makes a search of its storage, that is the database, or a number of standard or completed process plans that had been previously developed by the experienced process planners. So we have a data set, we have a database where there are plenty of process plans which are prepared by experienced process planners. So this development of database requires substantial knowledge of machining and the time required, and it involves more effects of the process plan. Using current data supplied by the CAD system, it searches for the process plan that are based on the part of similar design. So similar components, already process plan we are having, this is similar to this component, we take that process plan, and this plan is retrieved and is modified, that is edited suitably to the current existing component to be produced. So we can see the flow chart. First we are deriving the GT code for the part. GT means group technology. As I told you, group technology is grouping the components similar to their geometrical shape or manufacturing process. And this according to this family file, according to this GT code, it searches in the part family file. And the part family file we have standard process plans. The standard process plan is retrieved by this system, and the required editing is done. So the process plan is for the family, for a component which is similar to our current component. So we may need, the dimensions may not be changed. So we have to make some alterations, some editing in this existing process plan. And we are preparing a new plan. This plan is then, these details are given to the process plan formatter, which formats the plan and produces a process sheet in the required form. This is the output of the process plan. So this planning is based on the principles of group technology and parts classification and coding. As I told, group technology is grouping of similar components, and you are classifying as with some coding system. This approach of process planning is also known as, already told, retrieval computer-aided process planning system. The task of the process planner now becomes one of modifying the existing plan to suit the dimensions of the current part. So we are having a process plan for a similar component already prepared. We are taking that plan and we are modifying it, we are editing it to suit to the required current part dimensions. The dimensions may not be same, so we have to make some minor changes in the process plan. So one of the prerequisites for implementing this method is that the industries must develop a large computer database of standard completed process plans. That is, the company should have a database which has a plenty of already prepared process plans. So in addition to this, we need only computerized drawings. So the drawings, part designs will be developed using a CAD system. That is the requirement of this planning system. So generative type process planning. It is defined as a system which creates process plan for a new component automatically without human involvement. The computer processes all the information in different databases and creates manufacturing database for a new component. The process selection, sequencing of the process, and other decisions are made by the system. Once the design of the component is fed, just we are feeding only the design of that part to the computer system. It does all the work and generates a sequence of operations for producing that component. So we can see in this diagram. So parts description database, manufacturing database is there, Knowledge base is there and decision logic. Decision logic will tell us how to prepare the plan. So inputting all these to the generative computer-aided process planning system, it produces the process plan. For the generative process planning, there are many softwares available. Some examples are Autodesk Fusion 360, Mastercam, etc. So I told the decision logic, it has the ability to check the requirements of the component and generate a process plan. Selection of machines, tools, and all are done automatically in this method. So merits of generative process planning. Generates process plan quickly and consistently. It can be used for both new components and old components. It can be also interfaced to the automated manufacturing system. It provides online control information. The advantages of computer-aided process planning. It produces accurate plan, consistent plans. It reduces the cost of process planning. It reduces the lead time of process planning. It increases the productivity of the process planning. There is no need for the skilled process planner. The disadvantage, the main disadvantage of computer-aided process planning is the initial cost involved in it to establishing the computer-aided process planning setup, and also inability to source special manufacturing techniques. Thank you.